Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench, we're going to take a trip off the beaten path. We're going to look at something a little different. This is a Philips. This is an EL3542A tape recorder. And this is a very early, this is a vacuum tube tape recorder from 1960. So that places it probably, what does that place it at, 65 years old now? You can see the condition. It's quite dirty. Heavy dust. It's been sitting for a long time, and it's kind of beat up too. It's got some scars, some battle scars here. It's got a cloth wrapped case, wooden case that's cloth wrapped, and it's got some nicks and cuts in it and pieces missing. It's quite dirty, but this is an interesting tape deck. I was just doing a little bit of research on it before I turned the camera on, and I just want to go through some of this. I'm going to read some of this for you here. I found this on Radio Museum, and it says, high quality 4-track 3-speed tape recorder suitable for domestic or semi-professional use. Now that's a bold claim, semi-professional. But you got to remember, this is 1960. 1960, yeah, this probably would have been something high-end for 1960 that people would have used. It's portable, and you could carry it around with you, and it probably performed pretty good in its day. Features a 4-track reel-to-reel system offering playing time on 3 international speeds, 2,400 feet of tape of 16 hours at 1 7/8 inch per second. 16 hours a track. Okay, that's a lot of recording time. It's a lot of voice. So I'm assuming that's 8 hours per side because you flip your tape over. 8 hours at 3 3/4 inch per second and 4 hours at 7.5 inches per second. Simple track selection switch. Now this is what got me here. This is what I was really blown back by when I read. It has an extended frequency range of 50 hertz to 20,000 cycles per second at 7.5 inches per second tape speed. 50 hertz to 15 kilohertz at 3 3/4 tape speed. 50 hertz to 7,000 kilohertz at 1 7/8 tape speed. And it's got piano key push button controls for simple and foolproof operation. And then it gets into more details here. Mixing facilities with separate volume controls for each input. It has a monitoring facility. It has a trick switch, which is superimposing or a dubbing facility. A trick switch, that's an interesting name. 4-digit program indicator, which is just a tape run indicator. Pause button with interlock facility. Standby button, fast wind and rewind with friction braking. Public address facility, so you can use this as a PA. Just plug the mic in. Automatic stop with metallized leader tape. Okay, that's advanced feature from 1960. Recording level and on-off indicator with an EM81 Magic Eye tube. Tone control, which controls the high frequencies and down. A second channel preamplifier output for stereo playback. Okay, so this has a mono amplifier in it, but it has facility output on the back here to add a second amplifier. So you could run this as a stereo unit, which is pretty advanced for 1960, I'd say. Signal to noise ratio better than 54 decibels, while in flutter less than 3%. It has a 5-inch loudspeaker, output of 2.5 watts, supplied with hypercardioid microphone with music speech switch, radio connection cable, 7-inch reel, and it came with a 7-inch reel of tape and an empty 7-inch reel. So it was quite well optioned out. Now this doesn't have microphone or anything like that, and I don't see any provision for microphone storage. A lot of places, a lot of equipment from that area had a storage compartment for all the accessories, and I don't see a microphone for this one, so it's probably long lost. So let's have a look at it. So we got the front of the unit here. It's got Philips branding on it, and it has the speaker grill, and you can see it's quite dirty, needs cleaning. This is the right hand side. It's got a carrying handle And this latch, for whatever reason, as soon as I pulled this out of storage and started using it, this latch broke. Now this brass, I think it's supposed to be a brass spring, somehow fits in here, and it broke off. And now this no longer latches, so the lid latch is useless. On this side, we have some inputs and outputs. We got a speaker output. Now this does have an internal speaker, so we have the ability to add an external speaker. Has an external output for whatever, headphone output, phono radio input, and then it has a stereo output. I think this is for your stereo playback. This, you can add this to a second amplifier. Not quite sure. Back of the unit has nothing. Alright, here's the bottom. It's got a huge plate that's ventilated. So, you know, this is tube operated, so it's going to consume some current. And it does have a nameplate here. It's got the plate, let's see, it consumes 90 volt amps, so 90 watts roughly. It has a little compartment for the power cord. Power cord's original. And it's quite an interesting, unusual plug on that thing, and it's branded Pope. I don't know if you can see that. It says Pope on it. Never seen that before. So we got a little box here. I think this would also hold your microphone, I'm not sure. Spring loaded, so you can have your power cord hanging out. And then it's got an access here for our voltage selection. Let's have a look. So behind the nameplate, it's got a axis. We can just loosen these two screws, and then here's our voltage selection. Right now it's set for 110 volts, but we have the option of 220 or 245, and then there's a spring to hold that in place. So you would remove this, loosen this screw, swing this spring out of the way, pull your plug off, and rotate it to this arrow, to which voltage you needed to work at. Alright, let's get the lid off and have a look inside. So this lid, it used to have foam cushions here to hold the tape reels in place, but there's totally degraded. And we also have a High Fidelity badge to give you confidence that this is High Fidelity. And here it is. Very interesting styling for 1960. It's got a gray hammer tone paint finish, the white plastic, ivory plastic, and the gray plastic going together. It kind of looks pretty good. It's got a Phillips badge. So we have, let's see here, our controls. We got play. Ooh, that's stiff. Very stiff controls. Stop, fast forward, and rewind. Yeah, this thing needs lubrication badly. Record. I guess that's a lockout for your record. Pause. Interesting. It's not latching. It is latching, but you have to... Okay. This lever here, I'll show that in a bit. And then we have our tape speeds. 3 tape speeds to choose from, with a button to turn it off. Very stiff. Okay, here's our magic eye indicator. I think this tells us our recording levels. And then we have a track switch here. It says 2 to 3 up here and 1 to 4 down here. This whole thing is going to need relubrication because everything is really stiff and hard to operate. We have an input here or something. I think this might be our microphone. Doesn't say, it's not marked. And then we have a coaxial potentiometer. That's marked off from 0 to 6. And they are independent of each other. So that's the only potentiometer I see at the moment. Got our 2 reel tables, plastic. And this plastic has survived the years very well. I don't know what kind of plastic they use, but usually plastics of this age are already dried, cracked, and decomposed. This is our tape run indicator, so it's resettable. Set that to 0. Okay. And then we have our head block. It's covered with a removable cover. Got an erase head and our playback record head. Well, let me flip this around so we can see. Let me zoom in. So we've got a capstan and roller, record playback head, this massive record playback head, and then we have our erase head. This lever here functions from that. What that does is it pulls the tape away from the heads, or the erase head anyway. This might be your dubbing switch. So when you're recording, you can lift the tape away from the erase head and then record over top of the track that's there, and it would like mix. I'm assuming that's what's going on here. And then we have an electrode here and a post, and this is our tape sensor switch. There's a metallic foil on the tape. It'll short these 2 out, and that's where you get your signal from that. So if I put this in play mode, oh, there's play mode. Everything comes forward. The roller hits the capstan. Let's see here. And then there's a pad and a cushion, pad and a spring that comes up against the head to press the tape against the head. All right. So tape loading on these is really easy. You just drop your reel in place and get it to drop onto there. Okay. And then all you do is just lay your tape across this groove, and it should automatically fall into place. And then you get it started, and then it should all work. And then your tape should be in the correct position, which is very simple and ingenious for the back in the day. So I'm going to place your bets and see if this thing's going to just power up and work. I have a feeling it will. Let's try it out. So with no instructions, I'm assuming the way this works is there's no power switch on this. There's an off button. So to get this thing working, you have to select your tape speed, whatever speed you want to run with. So let's click that. See, that doesn't want to latch. Controls in this thing are really in need of lubrication. So that should set up the power for the amplifiers, turn the motor on for the correct speed, and put it into a mode where it's in standby. So let's try that. Let's plug the power in, and we'll see what happens here. And we get nothing. Okay. So that stands to reason. Let's pick our motor speed, and we get nothing. 70 watts of nothing. Okay, so that tells me the motor is seized. You can hear humming. No, actually, you know what? I hear a motor spinning. No, it stopped. Getting 80 watts. Okay, let's open it up and have a look inside. There's something not right with this thing, obviously. Here, let's set it up in the play mode and then turn the power on to see. Yeah, it's not working. You can see the motor is trying to pull it, but it's just not strong enough. Yeah, this thing's... that shouldn't happen. Why is it stuck? Okay. On top, there's only 3 obvious screws here. There's one in the center. You remove these 3 screws. Usually there's some on the lower front corners. Let's see where this gets us first. Some of these old designs were interesting, and they were very creative on how they put things together. Let me see here. Yeah, we are going to have to remove this gray plastic somehow. And I don't think it pulls off. Maybe it does. Hang on. Oh yeah, it does. Look at this. Okay, remove these knobs. Let me see here. Let's remove these knobs. Oh, they're on tight. Don't want to break anything. It's so... I have to give it a good pull. There we go. It's coming now. There. So this should remove. Yeah, that just presses on. And it reveals 2 more screws. That's what I thought. So let's get this. I'm going to remove this cover. It's unplugged right now. So you can get a good look at the mechanicals now, or some of the mechanicals. This is a very mechanical device. It's going to have a lot of weird things. We've got our eye tube here with insulating sheets. This is the grease. It's kind of red grease, and it's actually still very, very good. But that will all have to be replaced because it is not responding well. Okay. And the head mechanism, if I put it in play, you can see this comes up like that. Here's the pad that will need cleaning. Grease head. Okay, so let's remove this. So this is quite a complex device for 1960, gotta say. It's a very mechanical. Got a massive flywheel here. It's about 6 inches in diameter, if you can see that. We've got our main motor down here. It might have 2 motors, I'm not sure. But this one here, the belts are intact. These rubber tires are good. That's the thing that impresses me about these old machines, is the tires and the belts are usually pretty good. The tape counter belt is still intact and in place. So we probably don't need to replace belts on this thing. Probably just need to clean the pulleys, clean the belts, and reassemble. If you can see down here, there's the fan motor. There's a motor down there with the fan. Let's try this again under power. And we got to be careful here because there will be high voltages all throughout this thing. So let's plug this in and let's hit play. How come we got no power now? Okay, I did not select the speed. Well, it's working now. Okay, you got increased power consumption. So I have a feeling the cap in this thing is bad. I was watching the power consumption climb up. Okay, the more I play with it, the more it's coming back to life. It seems like the bearings are starting to free up. And one thing I want to do is I want to make sure that the main filter caps aren't in a position where they're going to explode from leakage, current leakage. So I think the best thing to do right now is I want to pull the back cover off. Or no, actually, you know what? I can just remove this whole chassis from the case. There is 4 posts on each corner, one in each corner. Looks like a nut and a stud. If I just remove the nut, this whole thing should lift out, and we can go and flip it over, and we can just give the electronics a good looking over and making sure that everything's good there. Do have a schematic for this. Don't want to do any more damage by putting power to it in this state. I know it's kind of irresponsible doing that, but whatever. We're here to fix it. If anything goes wrong, we're going to fix it anyway, so I don't want to wreck anything here more than I have to. But it's looking promising. It's going to be a lot of cleaning and relubrication. That's the main theme of this one, it sounds like. But I'm pleased that the belts and tires look like they're intact. So this is it's going to be a good project, I think. So I'm looking at this thing, and half of me is telling me just put the lid back on, close it up, put it back in the time capsule, and forget about it. And the other half is saying, well, let's go through and do all the work. I see a tremendous amount of work in this thing. Bearings, all these slide points, you know, all this work. It all needs to be going over and worked. But, you know, the more I played with it, the more it was coming to life. I really do want to see if this thing works in its current state. And I think it will, because the belts are all intact. Tires are here. My biggest concern right now is the power supply and the 65-year-old electrolytic caps. Here's a look at the power supply section. So we have a switch, SK7 is the main power switch, and I think it's tied in with one of the piano keys, and then it goes, where does this go? I think the motor connections go to the primary somehow. The motor connections, this doesn't make sense to me, but well, it doesn't matter. The motor comes on, motor turns off. So we have our filament winding on the secondary, and then we have our main high voltage. And so what I should do is I should just get a voltmeter out and check if we have our B plus here. We got a 280 volts, 250, 220 volts. And those are our main supplies for the amplifiers. And this capacitor here is a triple capacitor. It's got a 50, 32, and 32 microfarad. I just want to make sure that when I power this thing up, this cap isn't going to explode on me and cause all kinds of trauma. So let me get this thing out of the chassis. Let me get this thing out of the chassis. We'll flip it over and we'll check the health of those capacitors. And we'll see if they can survive a 5 or 10 minute test of being powered on. And then I want to put load tape on this thing and see if it works. Okay, if I remove the bottom cover, I think it gives us access to our electronics. Let me see here. Yeah, it does. Okay. Let me get this lid out of the way here. I think I need to do something with this power cord because this is going to dangle. Look at the size of that flywheel. It's incredible. Cobwebs everywhere. Okay. Okay, we are in. So this is what we're looking at. The speaker here, 5-inch speaker on the left hand side. And this is our main filter cap. There is a cover here. Let's remove this cover. Just loosen these 2 screws. I think these were built to be serviced, and they're very service friendly. Oops. I have the chassis unbolted, so it might move around a bit. Let's pull this cover off. Oh, and there's a screw on this side too. That's no good. And here I was talking about service friendly. So how do you get that one out? Anyway, so let's see here. Alright, so there's some Dutch here, but this thing says when replacing the fuse, put its roller on the hook protruding from the transformer. They got a little diagram here of this hook, and there's a roller. You can see the roller there. there's some date codes here, 23 of September, but the year is just a blob. I can't read it. I think it's 1960 or 50 something. I can't read that one either. There's another date code here, stamped on the inside. So what they're talking about is this here. There's this hook. I need a pointy device. So what they're talking about is this here, this hook here, comes on the transformer, and then it goes to this roller. I have a feeling this is just a thermal fuse. It's some kind of low temperature melting metal, and then when it gets hot enough, it melts and then it separates because this is under spring tension. I think that's what they're talking about. So that's kind of unique. You never see that. And I think, I don't want to play around with it because it might break it, but I think it's just held there by the spring tension. Yeah. And I upset it. Oops. See, I shouldn't muck around with that kind of stuff. Put it back where it should be. So this looks like all the electronics here, and there's our main filter cap. I'm just going to remove this cover. Get a better look inside. Slot of screws is the norm for this thing, and then this is a 5.5 millimeter hex. And that reveals point-to-point wiring for everything. This tube shield is non-standard. I don't know who put this here, but the disintegrating foam, I don't know if this is not the right tube shield. It does actually, you know what, it does fit here, but the spring wasn't in place. These tubes are mounted on rubber bushings, and that's to reduce microphonics, because these are very sensitive tubes and you're dealing with low level audio signals. So any tapping on that tube will create microphonics and put it into the audio. So any motor vibration or any vibration from the table it's sitting on will transfer in through the chassis to the tube. That's why they have them on these rubber mounts. The thing with this is you got to watch out for broken connections, because anytime you have any movement between something solid and something moving, you're going to have the potential for a broken connection. So these wires look all good. All of these caps here, the electrolytics, probably dead by now. But let's check this one out. Let's get some power going here. Should have 250 volts. What else? No, 280 volts, 250 volts, and 220 volts. So let's check that out. And here's a WEMA cap, 100 nanofarad. It's got a big crack down the side of it, and crack down this side. I expect all these caps will be garbage though. These probably paper caps. I don't think they had Mylar film, or maybe they did have film caps back in the day, but that's probably going to be the norm on this thing. There's a lot of these. There's, I can see here, 1, 2, 3, 4, 5 of these caps so far, and this one here has got a, like this, like I said, big crack. I don't know if you can see this. I don't know. Have a look at this one lug here on this capacitor, the one in the back. And you see something strange going on. There's a lump of solder that got left from the factory. Pull it out. There it is. Still a bit of rosin core flux that got left there. It's been sitting since it was constructed, probably. Okay, so I got my voltmeter connected to the B+. Let's see. Let's plug this in. I think it's switched on right now. I'm not sure. So let's plug this thing in. Let's see if the B+ comes up. 57 watts. Here it comes. 300 volt scale. And we have over 300 volts. And then it's settling down at around 295. So that's fine. Okay, I don't know if you can see this. It's probably washed out by too much light. Let's reconnect to the next one. I'll try that experiment one more time. I don't know which one this one is. This one is the red. This will be either 250 or 220. So let's try that one more time. It's going up to 270 and staying there. I don't hear any noise out of the speaker yet. Okay, so that might be the 250 line. Let's try this one. This would be the 220, I think. And it is at 220 right now and staying there. $225. So we might be okay on this cap. It's still cold. It's not consuming any energy. So I think what I'm going to do is I'm going to flip this over, load a tape, and see if we can get this thing to make a noise. Okay, I got high hopes for this thing. So I got it set for 3 3/4 speed. It's in stop mode right now. So let's just turn these right up. And let's plug it in. Got our motors going. Doesn't sound great. Let it warm up. So let's see if we can get any sound from the amplifier. The tubes should be warmed up by now. Let's hit play. It is working. So this is my test tape. Something wrong with this potentiometer. Let's see, the eye tube is lit. It's very faint green glow. Okay. Let's get past this noise. So this is amazing. This thing, I just pulled it out and plugged it in and it's working. It's gotta say something for the build quality of those years. Let's see what else we got here. Still more tone. Okay. I have to grab a different tape with some different audio on it. Yeah. Okay, let me get a different tape. Okay, take 3. So I got this melody tape, I don't know, magnetic recording tape. It is 1800 feet, believe it or not. I don't know what's on this. This one should have some kind of music or voice on it, so let's try this out. A whole lot of nothing. Oh, I remember what this is. This is recorded at 7.5. Let's try this again. Whoop, don't do that. This will be copyrighted, so I can't play it for very long. So we're going to go 7.5. Shut this off. Okay, 7.5.
They do what they are told. Take a little drink from the liar's cup.
That sounds good. That is doing really well. So, this thing just needs some love, and that's it. It just needs some lubrication. You hear all the noise from the bearings. Yeah, so we'll go through and we'll do some service on this, and then we'll get it put back together. Okay, update time. So I'm just starting to go through the electronics here, and I'm finding a few things out. I'm finding out that the resistors, for the most part, are pretty accurate in their values, and they're stable. I'm not going to touch them. Another thing I found out is the electrolytics actually are surprisingly holding up really well. And yes, they do need reforming, which I am reforming this one at the moment, and it's a 25 volt cap, and it's down to about 40 microamps of leakage current and dropping. But I'm going to let this go for about an hour or so, just reform it. And then there's one here. I think that's it. There's very few electrolytics in this one, and the main filter cap. And they're all holding out really well. The problem is with these brown WEMA caps, they are all done. These are all now resistors. Like this one here is 100 nanofarad, and it measures, I think it's like a 1.8 megohm resistor. All these are leaky, and so they're all going to get changed. I have one more to do, and I'm going to replace all these. Now the yellow capacitors are surprisingly holding up, and they have no leakage, so I'm just going to leave those alone. So between the resistors and the caps, the only thing I'm changing out is these brown ones, and everything else I'm just going to leave untouched because it's just working fine. And so I'm just about done. I have to replace this one. I want to test all these yellow ones. I tested a couple already. This one here, for example, I'm testing, and it shows no leakage. This one had no leakage. I'm going to go through and check them all. Yeah, so I'm pleased with this. It's going better than anticipated. Alright, let's start working on some of the mechanicals here. We got a lot to do, quite a lot to do. This thing's incredible. So the reel table, let's pull this brake back. This brake looks like it has a piece of cork on it, and it's intact. It's just dirty, so we'll have to give that a clean. And this should lift right off. And that's our reel table. And this is a friction surface, and then these pads have completely disintegrated. I don't know what kind of pad they had there. It looks like some special rubber, foam rubber. Let's see here. But it's kind of soft and spongy and crumbly. I happen to think that's some kind of a rubber, foam rubber that just completely disintegrated. So we're going to have to replace those. I don't know what would be a good choice here. Any kind of foam rubber I think I have right now would be too soft, too fluffy. We need something that has a lot of substance and rigidity to it. So I'm thinking maybe trying some leather. Cut some leather pads. So what we need here is we need this friction surface. It's like a clutch, right? That's exactly what it is. And there has to be some slippage, but there also has to be some grip too, because when this pulley, see, there's too much slippage there right now, and we need to be able to turn the take-up reel when it's in play mode, and then we also need it to kick in and do fast forward and rewind too. So there has to be enough torque for that. So let me try cleaning this off. I don't know what this is. Let's try some alcohol. Let's try a few things right now. Okay, here's some alcohol. Yeah, it's not really touching it. I have a feeling it's some kind of a natural or maybe synthetic rubber, I'm not sure. Let me try something else. This is contact cleaner. This is, what is this again? This is trichloroethylene. So let's try a little bit of this. This might destroy the plastic though, that's what I'm worried about. I'm going to try some right here. Yeah, see, it's digesting this white plastic. I don't know this plastic here. I think we're okay. Yeah, we're okay with this plastic. No, this isn't touching it either. Gonna have to find something else. Let's try some hexane. No, it's not touching it. I might have to just mechanically scrape it off. But it needs to be clean. It needs to be clean and smooth so that we have an even drag and even torque when this is turning. See, this clutch here coincides with this disc. Okay, let me see if I can clean this off somehow. So this here I cleaned. What I did is I took a screwdriver and very lightly and carefully scraped off the chunks, and then with what was left I just took a absorbing pad with some alcohol and just. But I realized after I cleaned this is not plastic. I thought it was, but it's just paint on the pot metal. So you want to be careful not to scratch this, I guess. You want it smooth as possible with no rough spots, because they'll catch and then you'll get uneven torque. Now I'm digging out at these these were pads. They were some kind of rubber pad that they stuck in that, because if I pull this out, you can see from the other side that there was a rubber plug or something they used, and it's completely disintegrated. So I think I'm just going to glue a leather patch right over top of this circle, and that'll be my friction point. And I think we'll try that first. We might have to get experimental here and try different things. But yeah, whatever that rubber was, it's pretty crusty now. So I have the chassis out of the case, and here's a look at the speaker. I call it a 5-inch speaker. It's in very nice condition. A little bit of dust on it. Phillips branded. Doesn't say how many ohms, but it's got a date code on it, 37 of 59. Okay, and it's just on a little piece of fiberboard. Here's the case. Quite dirty. I'm going to take this and scrub it and see how filthy it is. And the inside. Look at the construction of this thing. Like, who builds? This is all out of plywood and different blocks of solid wood. These little blocks here are solid wood. This is all. I'm assuming this is a plywood that's been steamed and wrapped on a form to conform to this shape. And I'm looking here, there's all kinds of production stamps, and so you see here they have, I don't know, this is 23 of September, and then I can't read that. And there's also some numbers here, another date, can't read those. But if I go over here, I don't know if you can see this one. This one here says 14th of October 1959. So that's one of the production dates. I don't think that's the final one. It might be a final production date, I don't know. But this thing came from 1959. So I'm going to take this thing and scrub it. I'm just going to put it in a sink with detergent. I'll probably remove the cover plate here. And I'm going to give it a good scrub because it needs to be cleaned and brought back Yeah, look at this. Nasty, nasty, nasty. I don't know what happened to it. It's even on the inside too. Whatever leaked came in through the speaker grill and went down and made a big puddle here. And this is big nastiness here, stained. So enough of that. I'm gonna get busy with that. Been looking at this mechanism here and trying to figure out what it does, and it's quite interesting. Well, interesting to me at least. I don't know if you find it interesting, but we have this. This is our pulley from the belt, and takes our drive from the motor and transfers it to the take-up reel. And we have this coaxial bearing or axle situation here. We have a thin axle, and we have a thicker one. So this one fits over top here, and that's driven by the belt. And then we have this one here. This one has a floating shaft, and it has this disc, this ivory disc. And what this is a clutch. This is a felt here, and it rides on this, so that when that's together, we get a bit of friction, not much, enough to make the wheel turn. And that's designed to make slippage. But this disc drops in this hole here, and that plastic falls into one of these holes. Okay. What's going on here? Okay, so it drops in, and then the take-up reel goes on that. Everything turns. Everything's nice. So what happens here is when it's in play mode, this wheel's spinning at a certain speed, but we have to have slip on this clutch so that this does not get too much torque and rip the tape. So it has to have slip here. So that's what's going on when it's in play mode. But what happens when it's in fast forward mode? Okay, let's put this on. See, there's quite a bit of slip there. We put it in fast forward mode. We press the button here. This lever pushes this, and what that does is I'll show you. Get it to drop in. There we go. What that does is it drops the reel table down probably about, I think it's close to 2 millimeters. It drops the reel table down. You can see as it goes down. And when that happens, this surface contacts these rubber bumpers that are now missing. And there's a direct connection here, a more direct connection, and less slippage because we have rubber on this painted surface and there's more grip, and that gives the increased torque to start rewinding, fast forwarding the reels. So what I need to do is find out something for, let's get rid of all this. What I need to do is find out something as a friction pad here, and I was thinking they had rubber plugs in here that completely disintegrated to dust. What I was thinking of doing is getting some leather and measuring the depth of this hole plus the millimeter or so protuberance I need over top of this, and cutting some strips of leather, rolling them up kind of like a cinnamon bun, and just dropping them in there, and then you'll have a leather surface here that can contact this and provide enough friction to give the fast forward a drive. So let me think about that. I could also take a block of rubber and whittle it out with a knife, make some plugs, 3 of them. There's going to be some for the other reel too. They're going to be disintegrated, so I have to make 6. So I might do that if I can find some suitable material. Rubber's okay, but I don't think it would last as long as the leather would. I think the leather would be ideal. Let me think about this. But this all has to get lubricated. And I need to actually remove this and relubricate inside here too. It's not totally necessary, but I want to redo this so it's perfect. And then if I look on the other side, the rewind has the same mechanics. See, when I press the rewind button, the reel table drops, and then it drops onto these disintegrated rubber pads, and same thing. So I'll just have to go through and duplicate everything I do on this side. So let me work on that today. I'll get that and I'll bring you back and I'll show you how it looks. Won't be able to test anything until everything's complete, so I'm not going to worry about testing right now. Another important thing is the shims. So this has shims to adjust the height of the reel table. The reel table height is important because the reel table height has to coincide with the height of the tape as it comes off the head and the head block. So we want that to be in line. If this reel table is too high or too low, then we have problems with the tape loading and unloading on the reels. So we got to keep that in mind too. So I'm going to show you a little bit more about the engineering that went into this thing. So we have a synchronous motor here. This is run off the line frequency, 60 Hertz in North America, 50 Hertz for Europe. Now I don't know if they use the same motor in North America and Europe. They might, and they might just transplant on a different spindle here. This spindle here has 3 different steps on it, one for each speed. The bottom one here is the quickest, and for the highest speed, then the 3 3/4, and then inch and 7/8 is up top here. And this is, we'll pull this off. This is coupled to the motor by a spring, and that's to reduce transfer of vibration, I guess. In this bearing assembly, I'm going to take this all apart and clean this. Pulleys need cleaning too. So, but I just wanted to show you this mechanism for changing the speed. So here's your 3 piano keys for the speed. You select one or the, depending on which one you press, it advances that idler tire and makes contact with the motor, and then it makes contact with the flywheel. It's got this huge flywheel back here. It's about 6 inches in diameter. And you can see from how it moves, the bearings are in like perfect condition and very low friction, very smooth. These idler tires, I'll have to remove them and clean them. The rubber is just, I'm amazed at the condition of this. The rubber is actually like new, and this thing's 65 years old, and the rubber is still soft, and you know, it just needs cleaning, and then it can be put back in service. So I want to take this motor apart, clean the bearings, it's loaded with dust. The fan is dirty. It's sucked a lot of dust through, so I want to clean everything, re-lubricate it, put it back together. Then I need to do this idler wheel assembly here, the bearing on top and bottom, disassemble that, clean it and re-lubricate everything. And then I have to do remove these 3 wheels, clean those. I'm going to do rubber renew on those, and then that should be done. I got the belt clean. Actually, I'm still cleaning the belt. And then I do have the reel tables ready to go. I have these here. I have leather installed, and I still need to shave it because it's not even, right? It has to be an even surface, so I'm going to shave that, and then that'll be ready to go. But we're making progress. There's a lot of work here, a lot of disassembly, cleaning, lubrication, reassembly, and this is quite a machine. All right, I'm back together again. This is quite a job, boy. It was something else. Got both reel tables disassembled, cleaned, re-lubricated, put back together with new pads. Got the belt out and cleaned. The motor, to remove the motor, service the bearings, re-lubricated, cleaned all that, and the spindle here was also the same thing. Now, idler tires, had to remove this whole assembly here with the piano keys and everything to get at servicing it, because it's all one piece. You have to remove these 2 screws to remove that, and then 2 screws back here to remove the block, and then you have to disassemble everything, clean it, re-lubricate it, put it all back together, and it's all working good now. So now the only thing left here is adjustments. I haven't adjusted anything, and I didn't do anything with the capstan roller flywheel thingy. I'm going to leave that. I'm going to focus my attention on lubricating all this mechanicals here. These switches, they're quite stiff on this side too, so I'm going to do some lubrication here, cleaning lubrication on these 6 keys and all the mechanicals that go with it. So I'll bring you back in. I'm not going to show you anything because it's really long, boring stuff. Okay, just going through and doing some power on tests, and I found this motor is quite noisy. So when I disassembled it, relubricated the bearings, I just put it back together. I didn't align it at all, and what it sounds like is the rotor is hitting on the stator, rubbing, and every rotation you get a little tick or a scrape sound, and it's quite noisy. So let's try and fix this. Well, what we're gonna do is we're gonna align this, and I'll show you how to do these synchronous motors. You can do this on any synchronous motor. What it is, it has an armature here that's held with 2 screws, and these screws fall right through to the other side, and this armature here is threaded so that it's, you know, accepts the screw. So they're clamping these 2 armatures together, and these armatures hold the bearing for each end. So if things are a little crooked or there is slop in this, so when you tighten it down it could be like this or like this. So we're going to fix that right now. Let's see, we're going to loosen these 2 screws and provide us with lots of slack. Back these screws out quite a bit. Okay, you can see how these end quite loose, right? And you can do this, you can tighten this down, trial and error, and get it right, but the quick way to do it is just get some plain paper and slip it in between the rotor and the stator. We're just going to provide an air gap for the rotor. Might have to move this a little bit and finagle this piece in. This one here is going to be tough. Gravity's pushing the rotor down this way, so if I can push this up and squeak this in. There we go. If I can get this to bottom out. We got our paper on that one. Get this one in deeper. There we go. So we got our paper on both, and that's centering our rotor. Okay. So then we just tighten down our bearings, end caps, and the armature, and it should be aligned now to the point where there shouldn't be any interference. Actually, what I should have done is I should have recorded the segment before I started on how noisy the motor was, but I forgot, so whatever. Let's pull these out. Okay, that's tight. We can pull these out now, and we should have a silent motor. Let's plug it in, turn it on, and try it out. And if it still makes noise, try it. Won't, you know, do it again. So let's plug this in. Silent now. That's what I want. You can hear it humming, but the motor's silent. No more rubbing noises. Okay, so I'll put this back together. Okay, I went through and did all the mechanical re-cleaning and re-lubrication. A lot of this took quite a while. Piano keys, everything to this regard. It's all working now, and it's working a little better than when it first came in. Now, the biggest problem I had were these stupid clips. I should zoom in so you can see one of these clips. These style of clips here, I've seen these in Panasonic machines too, but I've also seen them in a lot of other European equipment. These are real pains, and if anybody knows of a tool or a pair of pliers that are built for these, I think there's something that has a special hook, and then you can hook on these two tabs. But these are all different sizes, so these are the big ones, and then there's smaller ones. The smaller ones you can just pry off and get them with a screwdriver. These big ones not so much. And I shown in another video a method I use to get these back on. Is I use a flat screwdriver like this, and I use the wedge of it. See how it's wedged? And what I do is I put the clip on the wedge portion and work it down. You can see how it's scraped up the screwdriver here. What's wrong with the focus in this thing? Try that maybe. You see how it scraped up the platings on the screwdriver. But when you put it on and you push it down onto the wedge, it spreads the E-clip, or the clip here. And then you can get it over the post, and then remove the screwdriver and it clips on. It's awkward, but it does work. So here's a small one. This one you can just manipulate with a screwdriver, put it on and off. But if anybody knows of a tool or device for these, let me know. I've looked on eBay and I don't know, I haven't seen anything. I don't know what it would be called. I don't know what these clips are called. So if anybody knows, let me know. And I recently had a question about that too in the comments section. Somebody was asking about these silly clips, and I really don't know what to tell them. So like I said, everything's re-lubricated, ready to go. The tape transport area here is, or the head block area here is all clean and ready to go. I got the controller re-lubricated and cleaned. Capstan's clean. Mechanicals are all good. Now, one thing I'm not going to touch is switches. Reason being is they're inaccessible in a lot of areas. This one, for example, I can get to some of the contacts, but not all of them. There's another switch down inside here. There's a couple switches, and they're completely blocked from any access. You have no access whatsoever to work on them. Even if I flip it around the other side, it's covered with a plate. And here's another switch back here that's completely buried. There's no provision for treating these switches, but then they don't really need treating because they're all wipe action switches and they keep themselves clean. As soon as you start using the switch, they clean themselves and then everything's good. So I'm just going through and cleaning, just general cleaning of the dust. I'm going to clean some of this dust out of here, put it back together, and I am ready to the point where I want to put a tape on this and give it a test. Before I put it back into the case, I'm going to give it a test, and then we'll take it there. But right now I'm just going to finish this cleaning. Okay, so it's together, it's working great. I think I got this one dialed in. There's a lot more I could do. I could do recording and playback amplifier adjustments for equalization. Now I did notice I was listening to some of the signals coming out of, there's an output jack here, and I connected it to an amplifier, and it has kind of an equalization applied to it that's not normal or not standard. And I'm wondering if that's some kind of early tape equalization they're using in this machine. I don't know. There's no mention of it in the specs. But they do talk about doing adjustments for the record. Let's see here. To press the record button. Frequency response curve for the radio pickup input. Frequency response curve for the microphone input. See, there's different adjustments here. Let's see what else. Playback amplifier. Okay, frequency response curve measured at the loudspeaker. and then overall frequency response curve. So there's some adjustments and there's some room for improvement on this machine for sure. I could probably dial this in if I spent the day doing test recordings and playing back and doing, you know, frequency response sweeps and stuff. I could get it all dialed in. But 2025, who's going to use this today for any serious recording? This is more of a novelty vintage piece. So what I want to do is I want to do a test video and post it separately like I typically do, because this is all copyrighted material, so I can get around that by doing a test video. And I'm going to do that. I'm going to port it. I haven't decided. I think what I'm going to do, instead of having you listen to the speaker and on the camera microphone, I'm going to port it directly from the machine to the camera, and then you can hear for yourself what this sounds like without any distortion coming from the room acoustics, the speaker, the camera microphone. So I'll do it that way. I'll do that next, and then we'll wrap this up. Yeah, I'm pleased with this machine. It's really running great, and yeah, I've been listening to it for the last hour here, and it sounds good. So what did we do? All in all, we put 5 capacitors. All 5 of these capacitors are bad. That's 100% failure rate of these, and these are, like I said, these are. I'll get you a look at one up close here, so you can see what it looks like. It's a brown branded WEMA, and this one's 100 nanofarad at 500 volts. And I believe these are paper caps. They're wrapped up, look like candies. So those 5 were replaced, and that's all I did to this machine, other than cleaning and lubrication. It's quite a testament to these, to the build quality of what they did back in the 50s. They built these things to be serviceable. They built them to last, and they built them to be rugged too, because this is all in a case that's transportable. So I'm going to end this one here. Thanks for watching, and hopefully we'll see you on the next one. I got lots of stuff coming up. Hope you enjoyed this, and we'll see you on the next one. Thanks for watching.